Hello fellow AGD coders, and welcome back to another video. Some of you may have seen on the Facebook page that I've been playing about with manipulating pixels on screen, and these conveyor belts, which are animated, is one result of those little experiments. And as you can see here, we've got Miner Willy, and we have got two fully working conveyor belts. So they basically move, of course, as you would expect conveyor belts to do, and they also trigger movement on the player character as well. So they behave pretty much exactly as you would want. What you'll also notice here, as I'm jumping through the blocks, is that there's very, very little screen corruption. It happens a little bit there at the very edge, but in general it doesn't cause anything like the kind of problems that you might get if you were using put block to create an effect like this. So obviously that's a big advantage. It looks much nicer for the player, and it's always clear what is happening and what the function of those conveyors is, even if they do change just a little bit when the player hits the first block. So I think in general they are a little bit nicer than static conveyor belts. Okay, so let's take a look at how it all fits together. Obviously, as you probably guessed, there is a little bit of assembly language involved, and we've got it here stored at, this is address 31704 as in previous demos. You can load it in there. The code is pretty portable though. I think you can basically move it wherever you want, and I will make the source and the binaries available for it as well. So basically, yeah, that's that part. And what I'm going to do is, at the end of this video, the last part, I will go into the assembly, look at the source code, and explain to you how it all works for those that are interested. But I thought I'd leave that till the end because I know some of you might just want to load the binary and make the code work, and of course you'll be able to do that perfectly well without knowing how it actually runs in the background. Okay, so here we are in blocks. As you can see, I've got a block set up here, and the animation will occur on the first and the third row. That's what happens in Manic Miner, so I've designed it that way. You could change it in the code if you know what you're doing. And I've also set up a second block here to show you that you can use more than one block. You can obviously set it up with however many different types of block that you'd like to use, and make it look a little fancier, look a little bit nicer, whatever. These are set up as ledges. I think one of them there said it was special, but they're basically ledges. They should behave like ledges. If you prefer, you can make them behave like solid walls as well. And as you can see, I've got two here. One of them is 9 characters across, and the second one there is 10 characters across. And when you draw these in, you'll just have to make a note of the position that they're in on screen so that you can reference them in the code, which is here. So there are two parts to the code. The top part there is the visual part, and the second part is the functional part, if you like. So the first part makes it look like a conveyor belt, this part here, and the part down below actually makes it work like a conveyor belt. And those of you that have watched Paul Jenkinson's tutorials will know that he has done a video about conveyor belts, and this functional part was covered in that, and the code is very similar. But this first part here, where we're making it look like a conveyor belt, this is of course new. So we've got here line and column, and then we're defining opt. So opt, we're setting opt to be 9, and that's telling the code that this conveyor belt is 9 characters long. And the variable rand, can you guess what rand does? Well, basically it controls the direction of the conveyor belt. So you can have one which rotates left or rotates right. And just to demonstrate that, I'll change the number here to 4, and as you can see here, it's now only rotating those 4. Remember, this is just visual. We need to program it in, and to make it look right, we need to set it correctly. If I change this one to a 0, it's very easy to change, and as you can see, it's now rotating in the opposite direction to what it was previously. So it's that simple, really, to control a conveyor belt. It's very, very similar to the way that it works in Manic Miner, and this I felt was the the most practical way really of implementing it, and it's also the way that we avoid screen corruption, because it basically just repeats the blocks as many times as you need, and for that reason it doesn't cause any screen corruption, because it just keeps repeating itself. It refreshes itself, if you like, from the first block there. So yeah, as you can see here, I've put it inside a if screen equals 1, and that means that it'll only run on screen 1. You can obviously customize that, and down here we have the code which controls the actual effect of the conveyor belt, if you like. First thing we do is we check if can down. That's important because we don't want the conveyor belt or the custom block to trigger anything unless the character is actually standing on the conveyor. So that's why we test for if can down. It means they'll be in the right position. And then we're doing a check, simple check here. If X is 56, that's one of the conveyors, and if it's not that one, then it must be the other one. So it's as simple as that, really. And as you can see here, when I jump, it doesn't have any impact. So just like in Paul Jenkinson's tutorials, I'm using a custom block, and I'll show you where that is now. You can see the type is custom. I'll just put a letter C in here, and there you go. You can see where I've put them, basically across the whole conveyor belt, and they will be detected, and obviously they will only trigger when the character is walking on them. In other words, when they can't go down. So let's just clear that away, and we'll just move back into the code again. So yeah, basically let's just review. This part is the visual part. We've got the position, line and col, then we've got the length, and then we've got the direction, and down here we've got the function, which basically, as you can see here, add 1 to Y or sub 1 to Y is basically moving the player by 1 pixel across or back. So let's take a look at what would happen perhaps if we wanted to change a couple of things and edit it. I can show you how fairly straightforward it is. What I'll do is I'll delete a couple of these blocks here, like that. In fact, let's take 3 of those away, and then I'll fill it in with just standard platform blocks like that. Okay, so that's changing the visual side of it a little bit, and let's take a look at what would happen. And as you can see, because we've still got the definition, the copy of the conveyor belt that's over there is being drawn over the top of that block. So you could use that if you wanted to. It could be useful, but what we would probably want to do here is change it, and instead of 10 we've taken 3 away. We'll change it to a 7, and there you go. It's as simple as that. It's very, very easy to code, and so just obviously play about with that and experiment. And as you can see, because I've taken away the custom blocks as well, which I did just then, it doesn't work when he's on the platform, and the custom blocks are basically in place just over the conveyor belt. So didn't mention that when I first did it, but when I deleted the conveyor, I also deleted the custom blocks. Perhaps you noticed, but there you go. Okay, so that is pretty much how you control the visuals, but you can also control, for example, the speed here. If I repeat this assembly call here for this for the lower conveyor belt, let's take a look at what happens. And as you can see, it's now going twice as fast as it was. You could introduce a delay as well if you wanted it to go very, very slowly. That's also possible. But obviously, if I've now made it look like it's going twice as fast, I should also have it affect the player twice as much. So let's put sub 2 to Y in there, and as you can see, changing the speed of the conveyor now is as simple as just a couple of variables, and now the player can't move backwards unless they jump. So again, if you want to set it up like that, depends on the game that you're writing and the kind of style that you want to put into it, the puzzles, the difficulty, all of those kind of things. You'd be able to design levels like this relatively simply, I would say, because you're just putting the conveyors in, defining them in the script, and then just running the code. So it's really that straightforward. And to be honest, that is pretty much it really. I'll make it available for download. Okay, so to finish up, and you can skip this part if it's going to go over your head, but for most of you I hope it will be interesting. Let's take a look at the actual assembly language and how it works. So the first thing that we do at the start, and this is, by the way, this is very similar to the actual Manic Miner code. I had a look at that, and so I basically used that to as a template really to make it as similar as I could. So we start out here. We're starting out at 31704. You can change that because, as I said, it's pretty much portable. It's all jump relative, so it shouldn't be a problem. We've got two variables, opt and rand, which we already know about, and there's a little routine here called gprad, and that's built into AGD. And what that does is it will call a routine which basically looks at line and column and calculates the screen address. So that saves us quite a lot of extra work. If we just call that right at the start, it will go to the point in memory that you need. The next thing that we do is we basically copy from DE, because gprad stores the screen memory in the DE register, and we copy it to HL. And the reason we do that is because we're going to basically do both the left and right movement at the same time, as in the upper part of the conveyor and the lower part as it's moving. So we need to set up a loop, obviously, and that loop will determine the length of the conveyor belt, and we get that from variable opt. And variable rand here, we'll do an OR on it, and that means that if it's a 0, then it will be one direction, and if it's above 0, it will be another. So it's a very easy and simple check. And so we've got this jump if not 0 to right conveyor, which is down the bottom there, and that does an opposite rotation on the 2 bytes. Obviously the conveyor has 2 bytes, the very top part and the underneath part, which are going in opposite directions. That's what gives us the conveyor effect. So here we're rotating the byte. This is the left, moving in the left direction, this part here. So we rotate the byte just the once, and then we add 2 to register H, which moves us down 2 pixels, and we then load that into the C register, and then we rotate C in the opposite direction. Then we have a central loop here which basically copies those results straight over into the onto the screen, and that's essentially how it works. And this is the reason why it doesn't cause a lot of screen corruption, because it does the whole thing on only one block, and then it copies exactly what it's done over to the rest of the blocks. So we're not repeating our rotations or anything like that. We're literally just doing it on one block and then saying make X amount of copies. In this case it would be the variable opt. Make that many copies of the first one that you've already done. And that's why we're using both registers to do that, so that we can basically copy 2 bytes each time. And this code is more or less identical to the code that is used in Manic Miner. The only difference is that rather than 2 rotations, which happens in Manic Miner, this one only has 1, and the reason for that is that AGD code actually runs a fair bit quicker than Manic Miner does, and when I tried it with an exact copy, the conveyors were moving much too quickly, so I reduced it. Okay, so that's pretty much it. I hope you found it useful, and I look forward to seeing it in a game soon. In the meantime, keep enjoying the Spectrum and AGD, and as always, happy coding. Bye bye.